We are going to go over some common chemical vocabulary. So, the first thing we're going to talk about is matter. And matter is anything that has mass and volume. So, basically, anything that you can see, touch, or feel, anything that has mass and volume. An element is a substance that cannot decompose into simpler substances. By chemical or physical means. And so, of these elements, if you're looking at just one specific element, they are made up of atoms. So, atoms are the smallest piece of matter. That retains the chemical and physical properties of that element. Now, a compound is a substance with constant composition that can be broken down into two or more different elements by a chemical process. And so a compound is made of two or more atoms. And like I said, it's going to have constant composition and it can be broken down into the different atoms or elements by a chemical process. And a molecule has two or more atoms. I know that those are very similar in definition, but we will see that there is going to be a difference later on in this class. So, just a reminder that this compound has constant composition that can be broken down into two or more different elements. All right, we are going to talk about the scientific approach to knowledge. Many of you may have heard this referred to as the scientific method. So, the first thing that happens is people will make an observation. Natural phenomena and measured events can be stated as a natural law if it is universally consistent. And a tentative proposal is going to be what explains those observations and give a possible explanation for the observation. So we have the observation first, and then we can form the hypothesis. And this hypothesis is going to be, sometimes you hear of it as an educated guess or an educated idea. This is what I was talking about with that tentative proposal that explains the observation. All right, another way of thinking about it, it is a possible explanation for the observation. So you have an observation, you've observed the natural phenomena and measured events, and so you want to look into it a little bit further, and you can form a hypothesis. And from there, you will design experiments. And these experiments are procedures to test the hypothesis. Now, this is important. You need to measure one variable at a time when you are setting up your experiments. So, this is very linear, where you have your observation, you make your hypothesis, and then you do your experiments. You either make a law or a theory based on those experimental data. However, what happens more often than not is your experiment will show you that you need to go back and revise your hypothesis. That hypothesis is revised if the experiment results do not support your initial hypothesis. Now, a theory or a model is a set of tested hypotheses that gives an overall explanation of some natural phenomena. And a theory explains why something happens. And it is based on reproducible experimental data. There is this idea, people that are unfamiliar with science will sometimes say that is just a theory, or I have a theory, as if theories were just speculations, but that's not the case. Established theories have strong experimental support and are the most powerful pieces of scientific knowledge. They are not weaker than a law. They have the same experimental data that laws have. And well tested theories are as close to scientific truth as we can get. Now, a law also can explain what happens, but it more explains why something happens. And a law usually has an equal sign. What that means is there's some sort of mathematical equation that is associated with the law. Now, if new scientific data comes, new experimental data comes along, then we can change theories, change laws, but it takes a lot for that to happen. So we need to differentiate between physical and chemical properties. So physical properties can be observed or measured without changing the substance. Can be observed or measured without changing the substance. So another way of thinking about that is these are properties that a substance shows by itself. And this is without interacting with another substance. Some examples of this might be color. Notice I'm not saying a color change, I'm just saying the color. Melting point, boiling point, or density. Those are all examples of physical properties. Now, a chemical property is the ability or even the lack of ability to undergo a chemical reaction. So the ability or lack of ability to undergo a chemical reaction. So another way to say this is the properties a substance shows as it interacts with or transforms into other substances. So some examples of that might be if something is flammable or if it is corrosive. Those are both examples of chemical properties. Here are some chemical and physical properties of copper. So copper, a physical property of copper is that it is easily shaped into sheets. It's malleable and wires, which means it is ductile. It can be melted and mixed with zinc to form brass. Here are some physical properties of copper: the density, the melting point, and the boiling point. Chemical properties is that it slowly forms a bluish green carbonate in air. So that's why if you just have copper sitting out, you'll start seeing that color change. It reacts with nitric or sulfuric acid, and it will form a deep blue solution in aqueous ammonia. So notice that all of these are changing the identity of the copper. Changing the shape does not change the identity of copper. Melting it does not change the identity of copper. All right, let's look at physical and chemical changes. So a physical change is a change in a physical state. And this is very important without changing the substance. All right, and so it does not alter the composition or identity of the substance. So some examples of a physical change is ice melting, sugar dissolving in water. Now, on the other hand, a chemical change is a change from one substance to another. A change from one substance to another. So what that means is it does alter the composition. Or identity of the substance. And sometimes you might have multiple substances, and all of those substances and their identities will be changed. An example of a chemical change is hydrogen burns in air to form water.